Hello chemistry students. Today we are going to be doing our first video cast, and we're going to be talking about moles and representative particles. And this is what we introduced on Friday. At the very beginning it's going to be pretty short, so pay attention, take some notes. We are on page of our book. Let's see, first examples on 291 if you want to open up, and make sure you have your worksheet out from class on Friday as well. Okay? So we're going to start out just reviewing those first two conversion factors that we talked about in class, and that was dealing with the mole, and the mole being this very large number, which was 6.02 times 10 to the 23rd representative particles. And of course this conversion factor can be flipped, and we can also have it as 6.02 times 10 to the 23rd over 1 mole. These two things are exactly the same, and depending on what our given number is in dimensional analysis, we will be using them flipped back and forth. Okay, and so the next thing that we need to think about is what these representative particles can be, and this was also a review of what we talked about, but the particles can be atoms. Okay, so atoms could be right here. We could have 6.02 times 10 to the 23rd atoms of, let's say, calcium. Okay, or it could be lithium or anything like that. Any just thing from the periodic table. It can also be molecules, which is something like water, or maybe a diatomic molecule like Cl2. Also can be a formula unit. We do abbreviate this FU. I know, it's pretty funny. And that's going to be any type of ionic bond, where molecules are covalent bonds. Formula units are ionic bonds. So something like NaCl. Whoops. Whoa. Whoa, whoa, whoa. NaCl. Or something like with a polyatomic ion, like lithium sulfate. Okay, something like that. And then the last one is ions. So this is just the same thing as an atom, except for it has a charge. So obviously you're not going to have a carbon ion, because carbon doesn't form ions. So it would be like calcium with a +2, or sodium with a +1, or chlorine with a -1, something like that. Okay, so let's do a couple of these examples so maybe you can understand how this dimensional analysis and these conversion factors work together. So you're going to have one of two given numbers, and just at the beginning you're going to have either a number that is moles, or you're going to have a number that is a particle. And remember, these particles are one of these four, and it really doesn't change anything in your calculation. It just is going to change your unit or your label. Okay, so let's say our first given number is moles. So say we have 14 moles, and let's just pick one of these. Let's do atoms of calcium first. 14 moles of calcium, and we want to know how many atoms of calcium that is. Okay, because we know we're solving for atoms because calcium is an atom. So you have 1 mole of calcium, and this is always going to be 1 mole. It's never going to be 2 or 6. It's always going to be 1, because that's the conversion factor. Just like 1 foot is always equal to 12 inches, it's always going to be 1 foot. Okay, and 6.02 times 10 to the 23rd is always the number that's going to be in front of your particle. So in this case, we're going to write atoms of calcium. Okay. And as you can remember from our dimensional analysis unit, we did 14 times 6.02. We don't include the scientific notation, so we just bring up our calculator here, and we would say 14 times 6.02, and that's going to equal 84.28. And now we add on our 10 to the 23rd, because we're going to assume this is nothing. And so you're going to add it if it's on top, and so it's going to be 10 to the 23rd. We need to change this into correct scientific notation, so it's going to be we only have 2 sig figs, so it's going to be 8.4 times 10. We made this number smaller, so we have to make this number bigger. So it's going to be 10 to the 24th. And since moles and moles cancel out, our units are going to be atoms of calcium. And I know right now you probably don't see a huge use for some kind of calculation like this, but later on from atoms we can use that law of conservation of mass and look at how many atoms we have on one side versus how many atoms we have on the other, and kind of predict what we're going to produce a little bit better than we did last chapter. And then of course we can flip this conversion factor around. We can use when 1 mole is on top, and that would be an example when we have particles to start out with. So maybe we have 1.43 times 10 to the 14th. Let's use molecules, okay, just to change it up. Molecules of water, of H2O. And we're going to use dimensional analysis and this conversion here to calculate the number of moles. Okay, so in this case we're going to have molecules of H2O that goes on bottom because we need to cancel these out. On bottom, and then we're going to have 1 mole of H2O on top. Now, the number, sometimes we get stuck. We go, I don't know how many molecules are equal to 1 mole. It's always the same, 6.02 times 10 to the 23rd. Okay? And so now we're just going to take 1.43 and we are going to divide that by 6.02. Okay? And we're going to get, let's bring up the calculator here, 0.43 divided by 6.0, whoops, that didn't work, 43 divided by 6.02, and we're going to get 0.2375, and now we need to subtract these, okay, because remember, if we are multiplying, you add the exponents, and if we are dividing, you subtract the exponents. So 14 minus 23, that's going to give us a negative number. So if you do 14, and you don't want to rush this changes the answer a lot. 23 is going to give you -9. So our answer is going to be, let's go ahead and put this into correct scientific notation. So we get 2.375 times 10. This was -9. We made this number bigger. So we need to make that number smaller, so it's going to be to the -10th. And we only need 2 sig figs. So it's going to be 2.4 times 10 to the -10th moles of H2O. Got a little small there at the end. Sorry about that. Okay. So let's go ahead and do the first example out of the book. So I'm on page 291 right now, and this just says converting number of atoms to moles. And basically what we have skipped prior to this would be that dimensional analysis review and talking about how big the mole is. So this first one says magnesium is a light metal used to manufacture aircrafts, automobile wheels, tools, garden furniture. And so how many moles of magnesium is 1.25 times 10 to the 23rd atoms of magnesium? So since it said magnesium, we know to put atoms. If it would have said magnesium chloride here, we would have put formula units. Okay, so we put atoms of magnesium on the bottom, and we put 1 mole of magnesium on top. So it's going to be 6.02 times 10 to the 23rd. So we're just going to divide these two. And I'm just going to go ahead and look in the book here for the answer. And so it says when you divide those two out, we get 0.208 moles of magnesium. But we would have just taken that 1.25, that 6.02, and divided it, and then subtracted the 23 from 23, which is why we don't have an exponent over here. Okay, and we have 3 sig figs, so we're okay. All right, now let's do that sample problem 10.3. So we're on page 292, and this one is just going backwards. It's going to be giving us moles, and we want to convert them into the particles. So it says propane gas is used for cooking and heating. How many atoms are in 2.12 moles of propane? And propane is C3H8, and that's a molecule. It's a carbon compound. We know that's a molecule. And so we're going to put 1 mole of C3H8, and I didn't spell that wrong. That's actually how you abbreviate moles, by dropping the E. And we're going to put representative particles on top, and since this is a covalent bond, we're going to call this a molecule. So it's 6.02 times 10 to the 23rd molecules of C3H8. Okay, and you definitely need to write out all these, otherwise when we get into longer multi-step problems, you'll get really lost. So if we bring up the calculator here, we're going to have 2.12, gosh darn it, okay, whoops, 2.12, okay. And we're going to multiply that by the 6.02. I'll just use the number pad. How about that? And that's going to equal 12.7624. And now we're going to go ahead and put that 10 to the 23rd, since there's nothing here and we're adding. This is just going to be a positive 23. If it was on bottom and there was nothing, it'd be negative 23. And we're going to say this is molecules, oops, except we have to put correct scientific notation and significant digits, so I don't want to put that yet. So let's go ahead and put 1 point, we need 3 sig figs, to 8, because the 6 is going to round that 7 up, times, and we made this number smaller, so we have to make this number bigger, so 10 to the 24th molecules of C3H8, and definitely have to put the units in the answer that you box in, okay, and always box in your answer, okay? And then the next part is talking about the molar mass, which we already went through on Friday, but this is going to take us to that next step where we can start using atoms and going all the way to mass to see how many grams these atoms weigh, and that'll be our next video. So if you can master this concept of just doing the one-step conversion from moles to representative particles and from representative particles to moles, you have mastered this section for Monday. And Monday we will be doing some practice of this, and I'll see how successful you are before you move on. So have a great rest of the weekend, and I will see you Monday.